Hello everybody and welcome to my talk, Integrating Uyuni with Ansible and Terraform. I'm Christian and I'm an IT consultant at SVA, which is one of the biggest German IT system integrators, and I focus on topics like SUSE, Red Hat, Debian and other Linux distributions. Patch management is one of my favorite topics, I would say, as I was a Linux administrator when I started my career. I'm also part of the Uyuni project. I try to contribute as much as possible, for example, doing talks at conferences like this. I'm also interested in infrastructure as code, automation, because I'm a really lazy guy. So if there's something I need to do 2 or 3 times manually, I try to find a way to automate it so that I have more time to watch memes and cat pictures. And from time to time, I try to do DevOps, but most of the time it's rather DevOps, because I automatically crash systems, and I use tools like Terraform, Packer, or Vagrant. From time to time, I try to blog, and I'm also the co-host of various podcasts, most of them German-based. And today we're going to talk about one of my favorite projects, which is Uyuni. Somebody here in the room that has never used Uyuni before? Great, we are going to change this, I hope. Very good. So what are we going to talk about today? First of all, we're going to do a short recap and talk about which capabilities of automation Uyuni gives us. So there are already some things that we can leverage. Then I'm going to present the Uyuni Ansible collection and a very early Terraform integration that colleagues of mine developed last year. And I would like to use this as an opportunity to talk about the Uyuni API in the future, maybe. So let's get started with a recap. What does Uyuni offer us in terms of automation? Well, let's start with the XMLRPC API. Who knows that one? It has been there for a very long time. So if you started with Spacewalk back then 20 years ago, then you really might remember this one. So it always has been there, you can say. It is considered kind of legacy code, I would say. It's sometimes very painful to use, but it's there. At least we have an API. Yeah? So that's the good old default API that was introduced nearly 20 years ago. It requires some special client libraries. So there's a library for Ruby, there's one for Python. And a couple of years ago, the HTTP API was introduced. That's a new JSON over HTTP API that's way easier to consume. It was introduced in Uyuni 2022-05, and it is started becoming supported in SUSE Manager 4.3. So it is proven now that you can use it for your production environments as well. And you can use it for writing your own scripts that do things using the API that is also documented. But of course, we also have things like SpaceCMD, which is a command line interface to the API. So most of the things that you can do in the user interface can also be done on the CLI by using the SpaceCMD. You can write single-shot comments, or you can also use it like a shell and then do things like adding your systems, staging patches to them, rebooting systems. And it also has a wildcard mode, so it's a good tool to get started. And of course, we also have SaltStack, which is a mighty infrastructure as code solution for comprehensive configuration management. So maybe let's do a short poll. How many of you in this room have used the XMLRPC API for automating? I see some hands. Who use the new HTTP API? I see less hands. And who use the SpaceCMD utility? I see some more hands. And who is using SaltStack? Okay, the most hands go up for the SaltStack. Okay. I'm not going to be harsh about this. So both tools are good. SaltStack is good and Ansible is also good. It depends on your use case, but Uyuni uses SaltStack as an integral component, which is also the reason why it's named Uyuni, because this is the biggest salt desert in Bolivia. So that's a nice, funny wording. I really appreciate that. And Uyuni also started offering an optional Ansible integration beginning with Uyuni 2021-06 and SUSE Manager 4.2. So it's also out there for quite some time. And the reason why I put this meme there is, even though SaltStack is good, some people prefer Ansible because they maybe started with Ansible years ago when they introduced SUSE Manager or Multi-Linux Manager, how it's now called. So it depends on the use case. Maybe just a very, very short comparison between the big 2 configuration utilities. I'll consider them 2 as being part of the big 3. So we also have Puppet. That's even older and longer out there. Some people still use Chef these days, I guess, and SaltStack and Ansible are both nearly the same age. They were introduced 2011 and 2012, and while Ansible does not need an agent, you just need Python and SSH or WinRM, SaltStack offers an SSH-only option, but usually you have an agent called the Salt Minion. And both designs are in a push manner, which means that you, as the administrator, you push out your changes and the system's getting configured. Also, both tools are developed in Python and use YAML, but I would say that the syntax level of Ansible is a little bit easier than SaltStack, because SaltStack is more complex. You have a server-client architecture, you have a CA for making sure that only machines that are supported and confirmed by your infrastructure are getting configured. And I found out in various customer projects that people are more into Ansible because you can have a look at some tutorials, and after maybe 2 or 3 hours you have your very first playbooks and roles up and running. And the community is also quite bigger. That doesn't necessarily mean that it's better though, but we have the Ansible Galaxy with nearly 20,000 members, and we have the SaltStack Formulas GitHub organization, which has roughly 50 members. And we have something around nearly 4,000 collections and more than 35,000 roles, 500 of them being Apache roles. So if you want to go ahead and develop the 501st one, this is your chance to do so. So it doesn't necessarily mean that it's better because the community is bigger, but we can see that more partner companies like network manufacturers and so on tends to develop Ansible integrations rather than SaltStack integration. So it's from a SaltStack point of view, it's more community-oriented, and Ansible, being part of Red Hat as well, is more partner company-related, I would say. But both tools are very capable, and it depends on your use case. But I would say the majority uses Ansible these days because it's a broader range of predefined code and also tools. So speaking of Uyuni and the Ansible integration, so what changed in 2021 and 2022 is that managed hosts can have the Ansible control node add-on type. So this means from an Uyuni standoff point, this system can be used to run Ansible playbooks which are triggered by Salt. So it's funny combining two mighty tools to configure other systems. It's supported with SUSE Manager 4.3. And newer versions in the future might also come with a non-outdated Ansible versions, because right now the usability is kind of limited because the Ansible version is 2.9. I think the current version is something like 2.14 or 13. So a lot of things have changed between that. But this will change with SUSE Multi-Linux Manager 5.1, which is just around the corner. So this, I think, would be released maybe in July or August this year. And usually customers have already existing Ansible infrastructure. And because of that, the Ansible integration is not that useful right now, but this will change with newer versions of Uyuni and the Multi-Linux Manager. So this will bring newer versions of Ansible. Speaking of the correct version, it's 2.10 or newer, based on Python 3.11, not based on 3.6, like right now. And a lot of customers already have things like Ansible Automation Platform, AVX, or Ansible Semaphore. And this led to the idea of, why don't we develop an Ansible collection? So I'm working as a consultant, so I'm doing a lot of SUSE Manager or Uyuni installations. And I did not want to do this manually all the time because the steps are always the same and I'm lazy. So I was it would be great to have a collection for this. And I created a collection which consists of various roles. So for example, we have the server role that actually installs an Uyuni or SUSE Manager installation. I have a role for proxy servers, and I also have a role for bootstrapping new clients. So it doesn't matter whether I have one system to install or hundreds. It's just a very short amount of code that I need to write, and then all those things are done automatically. But besides roles, the collection also contains various plugins. So I had the use case for some of my customers that wants to have automatic patch maintenance. So they have hundreds of systems, and they do not want to use space CMD or manually click the patches into the systems. So I also develop plugins that automatically install package upgrades or patches, and can also do things like running openSCAP security checks and, of course, doing the Ansible and dynamic inventory. Because if you have hundreds of systems in your SUSE manager, you really do not want to write all that down manually in an INI file. So this collection is available on GitHub and Ansible Galaxy. I will share the slides later. Feel free to have a look at it and feel free to report bugs or just let me know what you think. Contributions and feedback is always welcome. And yeah, I would say I will show you some examples to get started with the Ansible collection. And the following example gets you a working SUSE multi-Linux manager in under 10 minutes. So this is a very basic Ansible playbook. If you have seen Ansible code before, this might look familiar to you. We basically have collection of hosts. We are using root privileges, and then we are using the stdevel uyuni.server role. And because we are installing the enterprise variant, we need to enter a registration code and the mail address for the SUSE Customer Center, which is entered here. Those are not valid credentials, so you can try, but I don't know whether it will work. We have one question in the...
Does it only work with Suma, not the open source variety?
It works with both. So if you leave the SUSE Customer Center's credentials out, then it will install the Uyuni variant. So we have both covered. Yeah, so this one will just install the most recent supported version of Multi-Linux Manager, which is currently 5.0.4, and in the future will be 5.1. And it supports both SUSE Linux Micro or SUSE Linux Enterprise Micro and SLE 15 SP6 and Newer, because those are the releases that are supported by SUSE. And we have some prerequisite check, and then we'll go ahead and do the magic. And as you just asked, how will this look like for installing Uyuni instead of SUSE Manager? So this is the example that I'm going to show you right now. We have yet another Ansible playbook, but we are also using the server role, but we do not have SUSE Customer Center privileges or credentials, but we have a very specific Uyuni release. So you can say, hey, I really would like to have a look at that 4-year-old Uyuni installation. We got you covered. You can do this. So that you can enter the specific Uyuni version that you want to install on your system. And there's also a very nifty tool that I really, really love. It's Base for Common Channels. Who heard about that? Some hands are raised. So that's a tool that can be used in order to create all those client repositories that you would need, for example, for Alma Linux, for Ubuntu, and other distributions. Because normally you would need to do this manually. That can be really pain in the ass. So people wrote a very long INI file that contains all the GBG keys, all the repository URLs. And you can simply enter the distributions that you want to see in your new Uyuni installation. And after that, it will create the channels and also sync the packages. So I can simply write down all in my playbook and then go to grab 1 or 2 coffee. And then I have an up and running Uyuni installation and already synced all my packages. But after that, we need to register clients, which is the next task. And of course, there's also a role for that. It's the client role, so this example shows that we're using the stdevel Uyuni client role, and that usually downloads and executes in bootstrap.sh script. So that's the script that you would need for unattended bootstrapping clients. It will add the temporary bootstrap repository to your new system, install the salt minion, register with Uyuni or SUSE Manager, and after that you're good to go. Just need to accept the salt key in your Uyuni web interface. So by default, it searches for a bootstrap file, including the distribution and the version. So let's say you would like to bootstrap an Alma Linux 9 machine. It would look for the bootstrap-alma linux 9.sh file. And that's usually on your Uyuni installation below SRE, www, htdocs, pub, and it's, you can create it. That's why we put the documentation link here. So. Okay, now we installed a new system, we registered clients. How do we patch them? This is what we're going to see in this example. Yet another playbook that installs patches. And for this, we have an Ansible module. It's the install patches module. You will need to enter your Uyuni credentials, so you can create a dedicated user that's only allowed to stage patches, for example, username, password. That's something you would really put into a vault. So you do not need to put it in clear text, but this is a demonstration, so I do not want to make things way too complex. And then you would enter the name of the system that you're going to patch, which is my server in this case. And you can also, if you do not want to patch or install all the patches, you can include or exclude patches. So if you have the exclude definition like here, it will install all the patches except the 2 listed in the listing. If you have the other way around, only supply include patches, and only the patches will be installed that you specifically mention in the playbook. So if you know there are some patches that are broken for your system, just put them there and they will be excluded. If you want to patch a lot of systems, so you saw that that's a single system that we are patching here, but usually you are patching tens or hundreds or thousands of systems at the same time, then the following playbook would be more sufficient for your use case. Then you would assign the group to the playbook. So now next to hosts, we see that we have a group called My Servers. Could be hundreds of systems in it or even more. We are running the task, but we are defining a loop. This is the last line in the code. So we have an Ansible inventory that's called My Servers, and we use all the systems that are in that list, and we delegate it to localhost. So the machine that's actually running your Ansible code does all the API calls to Uyuni. So basically what the whole collection is doing is it's creating API calls using Python to Uyuni. And you do not need to do this on the systems that are actually getting patched. You can simply do this from your Ansible control node. That will speed up things a little bit. And after installing all those patches, what would be the next thing to check? Security. Yeah, because if my system was secure before installing all the patches, you know that one, you install one bug fix and you got 99 bugs after that. So of course we're going to run the openSCAP compliance check, and that's the next playbook. So if we have a module for that, openSCAP run it is called. Of course you will also assign the Uyuni credentials for that one, and you can assign the document, the openSCAP document you're going to check. So this is a very basic example that comes with every openSUSE lib installation, and with arguments you can add parameters of the OSCAP command, so specific profiles in an openSCAP compliance document that you would like to check against. Okay, so now we saw some various examples how to actually do maintenance on systems, but how are we getting those systems into our inventory? I mentioned you do not want to do this manually on your own. And for that, we have the dynamic inventory. So that's another plugin. It's the SCDevil Uyuni inventory plugin. And you create an inventory file. Very important, the postfix must be .uyuni.yml. It took 2 hours for me to figure out why my demo.yml is not working, even though I created that plugin. That's why I put it in very special characters here, because I also forgot it from time to time. So it must be mycolab.uyuni.yml, and in that YAML file, you again assign the connection details like address, username, password, and these plugins also print out the custom values. So as some of you might know, in the user interface you can add variables, and those are named the custom values. And those values are also represented in Ansible. So for example, you can put in there your SAP system instance number per system, and then use this in your Ansible code in order to stop them in a proper way, for example, before maintenance. You do not want to patch a SAP system while it's running. Things can go really, really bad. You can also limit to various groups within Uyuni, and there's also a filter called pending reboot only, so you can only see those systems that actually require a reboot, and then do, after all your system maintenance, only reboot the systems that actually need a reboot. And I don't know why I put an IPv6 filter there, but I think there must be a reason for this. I don't know. So if you're IPv6 only, there's a parameter for that. So maybe one example, that's a demonstration I did for 2 years ago for SUSECon. We have a custom system information key. It's a SUSECon system as a variable. And if I run the Ansible inventory plugin, then you can see that this system is discovered as host, being part of the test host group. And it also shows the Ansible-related variables like the Ansible host variable, which shows the IP address. But it also shows the SUSECon 23 system variable. And as I mentioned, you can use this for automating your system maintenance. Which brings me to another demonstration that I did for various customers. So, I mean, patching systems isn't that hard. It's simply clicking install patches, submit and pray, and then wait and hope that the system is working after that. Yeah, so it's... Yeah, submit and pray is the really, really hard part. But the problem is, before hitting the install patches button, there's a lot of things that need to be done. Things like scheduling downtime for your monitoring, because you do not want to have night shifters getting waked up in the middle of the night because you're doing some patches. And maybe you want to make sure having a snapshot on your VM hypervisor, because if the system goes bad, then you can restore it from the snapshot. Been there multiple times forgetting this. So I developed a workflow that combines those. So this is an example from the lab. It's a VMware vSphere hypervisor for virtualization, CheckMK for monitoring, and of course Uyuni for doing the patch management. And this is an AWX workflow, but you can also do the same with Semaphore or AAP. They are Ansible collections that do all the magic for you, and this workflow will simply prepare maintenance by scheduling a downtime in the monitoring, creating a VM snapshot, and after that installing all the patches that are related to the systems. So, as you just saw in the slides before, we have an install patches playbook that actually does the same. It defines the connection details. It defines the patches that are going to be included. So in case there is no variable per system that only includes various packages, all patches will be selected, and it will be done on all the systems in the Ansible inventory. After that, we're going to run OpenSCAP, because after patching the systems, we want to make sure that they are still secure. And yeah, it looks quite fancy, I would say. It's an AWX workflow that first creates a VM snapshot in a playbook. After that, it will schedule the CheckMK downtime. And after that, it will patch the systems and check the compliance. And as you can see here, I think it might be too small, but that's the vSphere web interface. And we can see that there's a snapshot has been created, Ansible maintenance. So that obviously has been created by the workflow. Then we see here the CheckMK monitoring web interface that shows a scheduled downtime. And of course, we can see in the Uyuni web interface, in the events of that particular system, that patches have been scheduled and running OpenSCAP also has been scheduled. And this is the point where I'm very satisfied when I see that all the steps of my automation has working pretty good. We have green check marks, so yeah, green check marks makes me happy. So, yeah. And it doesn't matter whether it's one system or hundreds of systems, it's just running one workflow and hoping that everything works. Okay, who heard about event-driven Ansible? Some hands are raised, great. We got you covered too. So event-driven Ansible, for that people that never heard about that. So by now Ansible has been working reactively, which means a problem occurs, you write a playbook, you run the playbook, bad system is good again. So that's basically how it worked the last couple of years. And one of the very big advantages of SaltStack is that it has the ability to proactively react on changes. So I think it was called event-driven infrastructure, event-driven Ansible. No, that's not a copy, that's just, I don't know why it sounds like the same. So maybe to give you an example where this can be useful, let's say you have a couple of database servers. And when the hard disk is full, things really go bad. The database crashes and it needs to be restored from tape. Somebody needs to go to the basement, put the tape from somewhere and put it into the backup server. And you really do not want to have this happening. So it would be great to have an automatism that reacts before the database disk gets filled up. This is where event-driven infrastructure or event-driven Ansible comes into picture. You can do things like, okay, if I have less than 20 gigabytes of free memory, send an email and send an API call to my vCenter in order to add another disk that automatically gets put into the LVM volume group, for example. So that would be a use case. That sounds very interesting, but you really do not want to do this for all your problems you have in your IT environments. So you usually only do this for very, very specific problems you want to mitigate with this. And as I mentioned, event-driven Ansible is the answer for the Ansible ecosystem to address this. So yeah, EDA, event-driven Ansible. We have rule books in addition to playbooks that define events that are monitored. And those events can be filtered and actions define countermeasures. So for example, things like hard disk size, free, less than 20 gigs, fire up a playbook. That would be possible. And I was in a hackathon 2 years ago, and I was like, why don't we do something for Uyuni in that case? So it's a very early plugin. Feedback is wanted. It's rather POC than stable code, I would say. It can react when systems require a reboot. And for example, you could automatically assign the playbook to actually reboot a system. I think there might be better use cases. So maybe things like a system that gets unresponsive could be rebooted automatically. Or let's say a system becomes insecure, so the OpenSCAP score decreases, then maybe you want to automatically run a hardening playbook once again. And of course, if you have any ideas, feel free to reach out on GitHub or talk to me on the conference. So this is just a POC. Don't get too excited. But this is what it would look like. So that's a playbook that reboots systems. And we have some Ansible EDA references here. So we have a debug message that lists all the hosts that would need to be rebooted. So Ansible EDA.event.host is basically the information that gets delivered by the EDA plugin that we developed. And we simply fire the reboot host module that will reboot the system using the Uyuni API. So you will see in the history of the particular system that it got automatically rebooted. And running the rulebook is basically command, Ansible rulebook, and then it's kind of a background service that just polls after a couple of seconds and check whether there's a system that actually requires a reboot. So just to prove that it's working, or it has worked 2 years ago, I haven't checked it in the last 12 months, we can see here the upper part of the screenshot, it's the Uyuni web interface that tells me that this client system actually requires a system reboot, and below in the terminal you can see that hosts require a reboot, it's cut off, and then it will run the playbook. Okay, so this was basically the Ansible collection as it looks like today. As I mentioned, feel free to reach out and add some ideas. But we really like hackathons and we really like doing integrations for Uyuni. So last year, we participated in another hackathon in our company. And we were like, I never wrote Golang code, and I never learned Golang because I had no use case for it. Maybe we should do a Terraform provider. That's the first half of the story, but the truth is that we had an interview with the SUSE manager team, and while being on the record, they nerd-sniped us in like, why don't you go ahead and write a Terraform provider? And our answer was, we do not know Golang code. Okay, so what would happen if we sent you a book about Golang? Would you actually read it and write Uyuni code? We were like, nah, okay, maybe, because we thought we will never get a book. And 7 days later, Miguel sent 2 books to us, and yeah, okay. We really had to deliver on that one, and that's why we developed the Uyuni Terraform provider. So, speaking of Terraform and OpenTofu, who ever used it in this round? Okay, a lot of hands raised are raised up. So, basically, there's a broad range of providers for both Terraform and OpenTofu, nearly 5,000 providers by now, which is a lot. So there's basically a good coverage for mainstream and also niche integrations. But we figured out some things are still missing. For example, there are plenty of Git providers, but no for JO provider. And for JO is, at least for us, the way to go these days. So we started working on that one. And of course, I stumbled upon, hey, there's no Uyuni Terraform provider. So we thought it would be good to write some code for this. And that's how we started. So very first MVP was created in a 2-day hackathon. So it took 2 days from I never wrote Golang code to, okay, that's something that actually works somehow. So even though you're not experienced in programming like me, you can get into Golang code in 2 days. It is durable. And the MVP can create user objects right now. So it creates a user with a first name, a last name, an email, password, and a login name. It's not very special, I would say, but hey, it's like the hello world, maybe. So this is working. And I thought there must be at least some Golang code that addresses the Uyuni API, because I do not want to start from scratch by writing HTTP JSON requests. And I found that very sketchy experimental Uyuni API module in version 0.0.0. And I thought, hey, that's awesome. Let's depend on that, because this looks stable, right? So this is some very first code. I think Cedric wrote this, so thanks a lot for that, I would say. And of course, feel free to contribute. I already created an issue in the Uyuni GitHub organization. Maybe it would be great to create a dedicated repository just with the Golang Uyuni project. So once this is released, we will depend on that instead on the 0.0.01. But hey, it's working, right? So what this will look like is we have some Terraform code here. Of course, it's also working with OpenTofu. So it's a resource. It's an Uyuni user resource with a particular name, login, first name, last name, and so on. And we have an output that actually prints all the users that have been created within Uyuni. And this actually works. Yeah. So here's the output, what Terraform apply will actually do. It will find out, hey, there is no Simone Giertz user. Do you really want to create that user? And then you can hit the Y and enter button, and it will create a new user in Uyuni. It's awesome, right? So this was a really big achievement for me after 2 days doing the hackathon, because I really have no idea what I'm doing here, basically. And the concept of pointers still gives me strong headaches these days, but it's working. Which brings me into the discussion I want to start. How can the future of the Uyuni API can look like in the future? So I found out that in December 2024, an RFC was created and also accepted called Leveraging Open API Definitions. So some of you maybe already heard the Swagger utility. So that's the Open API definition. It's a widely recognized standard that offers a robust ecosystem of tools. So we have things like client generators. And speaking of the Terraform provider, this can be a daunting task, because basically what I did, I had to look at the Uyuni API, how is the user created, and how is the library working that I pinned to, and how can I make sure that the result of the API request gets handled correctly. And for Python, we have a lot of libraries for HTTP. We also have the same for Golang. But using the Terraform SDK gives you really, really long code. And boy, that can get boring. So if I think about putting all the Uyuni API calls in there, I would get even more gray hair. So it would be great to have the possibility to use client generators, which would be possible by using OpenAPI. Of course, we also have things like testing frameworks, and I consider having this within the Uyuni project would be a huge game changer, because we can simply use the definition, put it in a tool like Swagger to do some client generation, and it would be also easier for new developers and users to explore the API. We have a very comprehensive API documentation in the Uyuni documentation. That's good. But the Swagger utility offers things like fast search and generating code. So it would, for new users, be also a huge game changer, in my opinion. And of course, the automatic creation of clients. That would be interesting. Of course, it will not create 100% of all the code that we require. It would be dumb to think that, hey, this will solve all my issues. There will be other issues you need to deal with. There will always be issues you need to deal with. But I had a look at the Format project, which is also an open source patch management utility. And the Format project uses Python modules AppPy and AppInsible for developing Ansible collections. So they are generating client code. And they're also using things like Jinja2 for templating. And for Ansible, at least, there's a collections graph folding framework called the Ansible Content Builder. And they went down that road because manual development is too big and they want to leverage automation where possible. And last year at Config Management Camp 2024, there was a very interesting talk by Evgeny Golov and Matthias Delvig called Generating Ansible Modules for REST APIs Without AI. It sounds a little bit clickbaity, but they figured out very good why using AI is not good in this scenario. A lot of hallucination and code that's not working. And yeah, this is pretty common, I would say. When we have a look at AWS, they have a similar approach for generating providers from their SDK. So they wrote their own SDK. And I would like to hear your thoughts on maybe we could adopt something like this for Uyuni. It would speed up onboarding new developers and users and of course integrations heavily. So we would be able to have a fully covering Ansible collection, maybe just in terms of weeks and not in terms of months of development. So this would be really good, in my opinion. And we saw in one of the last Uyuni community hours that actually this was introduced, that this is something Uyuni developers are currently having a look at in adopting the OpenAPI specification for the actual API documentation. And I think once this is available for all the API codes that have been created in the last 20 years, we will all benefit from this. So I don't know, do you guys have any opinions or thoughts about that?
That's amazing.
Mike is coming up to you. So maybe you can repeat your comment for the stream.
My comment was on the AWS approach, which I thought was a real. I was already thinking in that direction. As soon as you put it up there, that there's also an easy way to extend that very quickly for development, which is to add your own services JSON extensions into a local development environment, which makes this a super fast method for prototyping.
Definitely.
Yeah, and jokes aside, right? Like the thing that's interesting about this is like I used to run Spacewalk in Uyuni instances before, and the biggest challenge I had with being able to plug it in and get everything all maintained and reacting is discovering what you can actually do in an automated fashion. And I think it would be very compelling if it becomes easy to have things like Python bindings generated from the Circo bindings or whatever, so that it can be plugged into existing infrastructure and frameworks and glued together. Like one of the challenges I had years ago was we had our machines receive monitoring through a mixture of Datadog or Zabbix, depending on what the infrastructure was living in and what security level it was. But then they were all centrally managed through our Foreman and Spacewalk systems, and being able to have those events trigger responses to do actions like apply a hotfix or whatever would be great.
Yeah, definitely. And I mean, a lot of projects these days follow the API first approach. So first writing the API and then automatically generating the code for integrations and the software. I mean, even SpaceCMD would benefit from this, because whenever there's a new feature, like content lifecycle projects is one of the very last features bigger features that got added into Uyuni, would be immediately be available in the CLI. So that would be a benefit. Okay, before we move to the questions and answers, I have some links for you. So documentation links to the Ansible integration, the HTTP API, and of course links to the Ansible collection, the MVP Terraform provider. And I also had a talk at this year's Config Management Camp. If you want to see me talking about coding, even though I have no idea what I'm talking about, check this out. And also I linked the RFC for the Uyuni Open API project. So, any questions from you people? Okay, well then, maybe that's a good thing, but I would like to thank you for your patience and taking part in this. Thanks.